Okay, so I'm not sure like why you don't know how to plot a graph, right? So I hope you can see the graphing calculator using the GeoGebra app. Okay, so to quickly draw a graph, what graph you want to draw? Okay, that depends on the equation you are given. Can you just give me a simple y equals to mx plus c equation? Y equal 2x plus 3. Okay, good. So given this, how do you draw using the GeoGebra app? I think it's pretty fast. You just key in y equal, key in here, y equal to x plus 3. Done. This is the one. That is how quickly you can use the GeoGebra app to graph the straight line. All right. So if you don't want to use the GeoGebra app, okay, which is a real time saver, real handy, then what you do, you just use the normal way, right? How do you do the normal way, right? So let me just get rid of this first. Then you just get the graph paper out. Do we have graph paper, by the way? Hello. No. Okay. So if you don't have graph paper, you should go and get yourself one set from your bookshop. Okay. Because ultimately you need to use this graph paper. Yes. Okay. Let me just get the graph paper out first. Okay. If you don't have that, I will just send. You can actually use the GeoGebra app. You just copy. Okay. Can you erase your handwriting first? So you can just use the GeoGebra app. Take a screenshot, and then you just print out this. Okay, that will be your graph paper. Okay, so up to you. You want to print out, or you want to buy a stack of real graph paper? Up to you. Okay, so I'm going to demonstrate to you how you can use graph paper. You can do the question manually. Okay. By the way, the lesson is recorded. So at any point in time, when you face problems at home, when you are doing the homework, you can always refer to the recorded video. I think I reply you with a link which you can refer to one of the questions, how you can actually graph a straight line out. Okay, so you are supposed to do the y equals to 2x plus 3. Y equals to 2x plus 3. Okay, sorry, hold on. Okay, y equals 2x plus 3. So the first job you do is, because now you don't have the app, okay, you can't just key in the equation. So what you need to do next? What do you think? No app. How do you draw the straight line without the app? What do you think? Okay, of course you need the tools, right? You need a ruler, and then but after that you have even before you have the ruler, what you need to do first? You need to know that a line is, yeah, of course. I mean, I'm not talking about the tools. Now basically you focus on the tools. I say what you need to do first. What you need to do first means what is your first step? Not the tools. I'm not talking about the tools. You need to understand that a line is given by joining all the points. on the graph paper. Okay, please let this idea sink in. A line is joined by points. So actually, if you join all the points up, then you get the line out, right? No points, how to draw line? You can't. Does it make sense? Does it make sense or not? Okay, yeah. Yeah. Okay. So whenever you get a graph question, okay, always look for points. Okay. If they don't give you the points, you create the points yourself. Okay. Like questions like this. I'm given y equals to 2x plus 3 by you, and then I'm not given any points, so I have to create points myself. So you create points by giving yourself a x and y value table. Okay, so you give yourself a x and y value table. So give yourself a x and y value table. All right. So you must be thinking, hey, what x should I choose? Right? What x should I choose? So since you just give me the equation, you never give me the range, right? So it's a free range. Okay. When you are not given a range, it's free range. So free range in this case for both the x and y axis. Okay. Why free range? Because I'm not given a range. So free range. Free range means I can pick any value I want. Okay. I can pick any value I want for x and y. Okay. And of course, I'm not going to use 100, 1000 because all these numbers are so big and they are going to make my life so hard. I don't want to make my life hard. I want to make my life easy, right? So you don't choose large numbers to make your life hard. Okay. So I think the numbers for x you can choose is, like I say, you can choose anything, but I would suggest you choose, probably you choose like -1, then negative, okay, after -1 is 0 already, right? And then 1, and then 2, then 3, then 4, and then 5. Okay. And then you must be asking me, hey, how many points do I need? Okay. Do I need like 1, 2, 3, 4, 5, 6, 7? Do I need 7 points? Not necessary. I think you can actually you are good with 3 points. Let me demonstrate to you. You are good with 3 points. So you don't need this much. Okay. But more points, easier to draw the line. More points when you link it up is easier. Okay. Let me demonstrate to you. Let me just go with 3 points. -1, 0, and 1. Okay. So now the question is, y equals to 2x plus 3. X is equal to -1. What's my y? Because I'm going to figure out my y here. Right? So next, -1, go in, you will get 2 times -1 plus 3. And you end up with 1. Use a calculator. Okay? Don't trust your mental calculation. I don't. Okay? So if I can make mistake, so please don't trust your mental calculation much if you can use calculator. Next, x is equal to 0. Oh, by the way, this part, right, you don't need to show it. Just use your calculator. Quickly get the value up. So y is equal to 2 times 0 plus 3 plus 3. Next, x is equal to 1. Put it in. Plus 3. Y is equal to 5. Okay, very good. So you have these 3 points. Simple. So when you get this, by the way, this is the, in fact, you can go on and on. Like I said, you can give it the 2, then get the y. You can give it the 3, get the y. Not necessarily. 3 points, good enough. If you are not given the table, free range, okay? Just given the equation. So now, this one, you can write as -1 and 1. -1, comma 1, bracket. So this is the format to represent a point on this x and y graph. So I write it in the format first. Okay. In the middle is a comma, by the way. Yeah. All right. So you don't have to write this down, but it's a good practice. Because when you write this down, it's easier for you to read later on when you plot the points later. I'm going to plot the points. So since I have these 3 points already, so this is my x-axis, which is the horizontal axis. This is my y-axis, which is my vertical axis. Okay. And then let me talk about the scale in this graph now. Okay. So no scale is given, so it's free scale. Number 2. So free range. Okay. I'm not given a range. I'm not given any value of x and y, so it's free range. I choose what I want. Free scale. What do I mean by that? Free scale. Free scale means for both x and y axis. Once again. What is free scale? Free scale means I choose what I want. So for the x-axis, let's assume this is 1 cm. So this is 1 cm, 1 unit. 1 cm to 1 for the x-axis. Similarly, this is 1 cm. So it's also 1. So it's also 1 cm to 1 unit for the y-axis as well. Okay. Okay. So in this question, free scale, I choose what I want. I make life easier for myself. 1 cm for 1 unit throughout x, or throughout the questions for both x and y. Okay. So what if the question says, hey, I want 2 cm to 1 unit for the x. So let's say it's not 1 cm 1 unit for the x. It's 2 cm for 1 unit. How does this change in the scale? 2 cm to 1 unit, change your x-axis. So 2 cm, so you just use 2 cm. This is 2 cm, right? 1 unit, right? So instead of the 1 here, now the 1 should be here. Then where is your 2? 2 cm after. So this is your 2. Then 2 cm later is your 3. Are you clear? And then of course 4, 5, 6, and subsequently. So are you clear how the scale will affect your graph? Okay, good. So I've talked about how your scale will affect your this labeling, okay, for the x-axis and the y-axis. Okay. Then what about if it's not a free range? What if I'm given some range for x and y? Okay, so let me just get back to the range for a moment. So let's say the range, okay, I'm talking about range, I'm talking about range now. Instead of free range, assume that you are given a range. So write down the range for x is, let's say 0 to 3. Let's say the range for x is 0 to 3, and both 0 and 3 inclusive, right? So what does this mean? This means you cannot take -1 for x, because the range is for x is you start from 0. Okay, you start from 0. So you start from 0, so you don't need this -1, right? And then you will end at what value for x? You will end at 3, right? Because 3 is inclusive with the equal sign here. So for this question, I need to go up to I need to figure out the y when x is equal to 2. So when x is equal to 2, 2 times 2 is 4, 4 plus 3 is 7. So 2 times 3 is 6, 6 plus 3. I don't need this 2. If I am given this range for x. Are you clear? Are you clear how the range for x and y and how the scale for x and y will affect your drawing? Okay. Free range, free scale, best. Choose what you want. Up to you. So now I can do this question already. So like I say, I might not, okay, in fact, you don't need these 2 values to sketch your straight line. Let me demonstrate to you first. Let me get the 0 and 3 out first. 0 and then 3 is here. Okay, this is your 0 and 3. So since I'm doing for this range 0 to 3, so I cannot take this point. Okay. So 1 and 5. 1 and 5. This one. Y, okay, so x comes first, y comes later. X comes first, y comes later. Okay. So when you put 0, 3, 0, 3, so 0 refers to the x value. 3 refers to the y value. Okay. So that's how you plot the points. Are you clear? So can you help me where is your 2 and 7 on the graph? Can you help me with the 2, 7? This is 2, 7, yeah. So they will intersect. Yeah, very good. Okay, so very good. So 2 and 7 is here. And then of course 3 and 9. Okay, 3 and 9 is a bit out of the graph already. But anyway, somewhere here. Okay, so with all the points, you can link it up. These 4 points. With a ruler and a pencil. Okay, so this is the straight line. And then the name is this. And the name for this is y equals to 2x plus 3. Okay. And by the way, my question to some of the students is, can you extend it? Can you extend it beyond? Can you see I extend it beyond? Can you see? I extend it beyond the y-axis. Can you extend this beyond? Depends. What's the range given in this question? So there is a range given for the x, right? So basically the range is to limit the length of your straight line. So over here it says what? The range is from 0 to 3 for x. So basically you start from 0 to 3. Anything out of 0 and 3, you can't draw it out. You can't draw it out if there is a range. That's how the range limit. That's why I just now, without the range, I have the -1. But with the range, I need to cross out the -1 and 1. So therefore, can you see that this portion of the line is out of the 0? I cannot extend it out. I need to stop. I need to stop. Stop at this point. So when you have the range, right? Let's say you have the range for the x 0 to 3, right? Basically, this range is to like a bound. Bound means limit. Okay. Don't go over. Okay. So range means there's a limit. Okay, 0 for the x is called the lower limit. This one is called the upper limit, which you can't get out of if you are given a range. Are you clear? Are you clear? Okay, so if there is no range, okay, free. But if there is a range, means you have the lower bound and you have the upper bound, which you don't go beyond or go below. Okay, all right. So that's it. That's how you draw a straight line. Y equals 2x plus 3. Okay, free range, free scale, or with range and with scale. Are you clear? You can give me a thumbs up so that I know that you're clear. If not, then you can explain how to graph a straight line further. Thanks. Oh, fat fingers. Nice. Thank you. Very cute. All right, then let's look at some of our questions. I downloaded it already, I think. Hold on, I'll take a while to load. I remember I downloaded it already. But never mind, just launch it here. All right. Okay, so for the first few questions, okay, for the first few questions is basically pretty simple. I think you get some of them are I get most of them correct, but let's go through them together. So it says what's the gradient and y-intercept for the following functions. So yeah, so these are called the functions. Okay, functions means just an equation. Okay, with some unknowns. Okay, so the word function, it means an equation with unknowns. Okay, unknowns means x is unknown, y is unknown. Okay, so they are called functions. So don't be alarmed next time when you see the word functions. Okay, over here, so you need to get this into the y equals to mx plus c format. Okay, so over here you can clearly see that you don't have the y, you have the minus y, right? So what you need to do, you need to divide by 1 first. So you need to do a bit of transformation first. Okay, so once you have done the transformation, you get y here on the left, and then you get 2x here, you get -3 here. So now you can compare to the format. So you get m equals to 2, and then c equals to -3. Okay, good. So you can actually use m here, you can use c. By the way, the m is okay. M and C, they are reserved letters in mathematics. Reserved means you don't use it for other stuff. Okay. All right. Reserved. Reserved for the graph questions already. That's why we use x and y, a, b, mn. Actually, mn is very seldom because we don't want to confuse students. Okay. Because m refers to a gradient. Okay. So it's reserved. So for 2y equals equal to this, so you divide by 2. Okay, so good. Then for this, you need to bring the 2x over, so it becomes plus 2x. This is plus 3, so it's 2 and 3. Very good. So for this one is so yeah. Then for this one is there is no. Okay, so for y equals to 3, right? So you compare to the mx plus c, right? You can see that the c is 3, the m is actually 0. There is no x. So the only way you can get rid of the x is when m is equal to 0. That's why your m is equal to 0 in this case. All right. Then for the last one, right? So it must have this format: mx plus c. Y is equal to mx plus c. That means you need to have a y first, and then this mx next, and then c next. And then you see that x is equal to -2, right? So no answer. Okay, no answer. Not 0, not 0, no answer. Because basically your this x is equal to -2, right? It does not match the format. It does not match the, the general format. The general format. Okay. So when it does not match the general format, no answer. Okay. Yeah. It's just like you does not meet the minimum requirements to go to watch a movie, so you can't watch the movie. Okay, simple as that. Okay, good. Yep. So I think I probably okay. Find the gradient. So what's the gradient for this question? So the hint is using the formula. Are you taught how to use the formula, or are you taught the formula to find the gradient already? Hello? Is it? Yes. Okay, good. So is m equals to 0? I don't think so. So if m is okay, I somehow I don't know how you use all this. I mean, how do you get all these numbers out without getting the m first? Then m I don't think is equal to 0. Okay. So what's the formula to find the gradient? Since you say yes. So what's the gradient? The gradient is m here, yeah. But there is no value here, right? Which you need to find. By the way, what's the formula to find m? The formula is actually y equals to mx plus c. But how do you find m? Yeah. Okay, this is the general formula for a straight line. Y equals to mx plus c. But m is equal to what? So looks like you have not taught the formula yet. Okay. So probably you are ready to do the, but anyway, it's good. Ultimately, you will face questions like this. Okay. So never mind. We just pick up skills along the way. All right. Let me just get rid of your handwriting first. Okay. So y equals to mx plus c is a okay, y equals to mx plus c. This is a straight line formula. This is a straight line formula. This is for a straight line on the x and y axis. I'm talking about y. I mean, I'm talking about m gradient. So the formula is called y2 minus y1 over x2 minus x1. I'm going to explain this to you using the PowerPoint and the graph we draw just now. Let me get it over. Okay, so this is the formula, right? But actually, there is a good thing. Okay, let me just get this, get it to the next page. Easy. No special. Just get, this is the gradient formula. So don't confuse yourself. This is the gradient formula. Y equals to mx plus c is straight line formula. Okay, so These are two different things. Now, you are given the y equals to 2x plus 3 in the previous slide. So in this case, your m is already given. Okay, m is equal to 2. C is equal to 3. Okay, so m and c both given. So you don't need the formula, right? Because you can read. Okay? You can read from y equals to 2x plus 3. Okay, but what if this question, this is covered, let's say cover, can't see, you can't see the equation. Okay, you can't see the equation is y equals to 2x plus 3. Okay, the only thing you can see is this. The only thing you can see is the table of value. And the graph. How? The only thing you can see is the table and the graph. So how do you get the m? If the only thing you can see is the table here. Okay? So if the only thing you can see here is the table, then you need to use the formula here. Okay, if you look at this table closely, right, you can see that you are actually using the second pair of x and y, the second pair of x and y minus the first pair of x and y. Okay, pretty clear cut, right? So you need to use the first pair of x and y minus something back. Oh no, bring to the front, sorry. Okay, so you need to use the second pair of the x and y. Why second pair? The 2 below denotes the second pair, minus the first pair. The 1 here denotes the first pair. So in fact, you have many pairs. So you have the first pair, you have the second pair, you have the third pair, you have the fourth pair of x and y here. Okay, so you just choose the first and the second pair. Okay, so that you can get the m. Okay, so let's do it together. So the first pair, that means this is my x1, this is my y1. 0 and 3 is my x1, y1. Probably I use a black color. This is my x1, y. Then this one will be 1 and 5 will be my x2, y2. 1 and 5. Done. Just put in the value. y2, 5. y1 is here, 3. And then x2, 1. x1, 0. So 5 minus 3 is 2. 1 minus 0 is 1. So it's 2. So m is equal to 2. Right? Now you can double check. M is equal to 2. Can you see that your m is also equal to 2 from the equation given? That's how you find out the m using the formula. Are you clear? I'm teaching you the second way to find the gradient, which is using the formula. Okay? Okay, once again, what if, like I say, this one is all covered? So bring to the front. So like, you don't know the m, you don't know the c. So I use the formula to find the M already. Then how do I find the C? Right? How do I find the C? Right? Simple. The C is called the what? The C is called the y-intercept, right? So the C means y-intercept. So what's the English meaning of y-intercept? The point it cuts the y-axis. Intercept means, let's say if you are speaking, I intercept you means I cut you off. Okay. So the point it cuts the y-axis. Then you look here. Where it cuts the y-axis. This point. The line cuts the y-axis at this point, right? Right? The point cuts the y-axis. So this is the point. So if I put a star there, probably it helps you. Oh, I seldom use star. That's why I'm looking for the star. So this is the point. So this is y equals to 3, right? Can you see? Can you see the 3 here? Okay. So this point is at y equals to 3, right? So therefore y is equal to 3 at this point. So your y-intercept, the y-intercept is one letter, C, not y. So C equals to 3. So C is equal to 3, M is equal to 2. Okay? And I'm not using the equation. I'm not using the equation. I'm using the table plus the graph to find out both my M and C. So I have the what M and C. Good. So y is equal to mx plus c. My M is 2, my C is 3. Yes, I get the equation. I don't need you to tell me the equation already. I don't need you to tell me the equation. Based on the table, based on the graph, I can find the equation. So this way of doing things is, so you are given the equation. Okay, at the start of the lesson, I'm given the equation. I draw things out. Right? Now, what I'm trying to say is you are given the graph. You also can get the equation. Are you clear? How they can test you? It's like you know how to go from your house to the tuition center. Over here. This is your house to the tuition center. You also need to know how to go from the tuition center back to your house. Okay, this is what I call left, right, right to left. They can test you from the left to the right or right to the left. Are you clear? Okay, so over here, this method is you need to use the formula for the M. So it's y2 minus y1, m2, not m2, x, sorry. Very simple. x2 minus x1. So the second pair of x and y minus the first pair of x and y. And then the C is the y-intercept. So just read from the graph. Okay, the point, just remember the definition. Sometimes they may ask you for the definition of y-intercept. The point, the line cuts the y-axis. All right. Okay, next. Let's look at our questions. Then over here, you must be asking, hey, what's my second pair of x and y? What's my first pair of x and y? You look at this. By the way, this is supposed to be not known. This is supposed to be not known. This is not known. This is not known. So For the entire table, you know this pair. This is your first pair. And then the rest, the next one, not known. Next one, not known. But this one is known. So this is your second pair. So with this, the first pair is -1, comma -1. The second pair is 2 and 5. So this means what? This means this is your x2, y2. This means this is your x1, y1. Okay, then just replace. Okay, just replace. So y2, 5. Y1, -1. So -1. Then x2, 2. x1, -1. So the minus sign is still valid here in between. So y minus -1, 6. 2 minus -1, 3. So the m is equal to 2. So in this case, your equation is y equals to 2x plus 1. Because your m is equal to 2. Using the formula. Okay, so m is equal to 2. Are you clear right now? Okay, good. Then with this, then you can actually complete the table. You can complete the table here. Then how you manage to complete the table just now without knowing the m? Number pattern, is it? Did you use number pattern? I'm not sure. Yes. Oh, okay. So let's get the y out. So your equation is y equals to 2x plus 1. So you give your -2 inside. It's -3. Okay, good. Then you put the 0 in. This one. Okay, good. Then you put your 1 in. Okay, good. Or you put your 3 in because the y is given. This one. Okay. Then you put the 7 in. Okay, good. So you see, I don't know how you get the values of x and y without knowing the m. So it's very surprising. There is another way, which is good. Okay. I see that you don't just stop. You don't just stop. You don't just stop right away. Okay. You try to use some other methods like number pattern, trial and error, guess and check. Okay. So your effort should be praised. All right. Okay, very good effort by you. Never stop trying. Right. Okay, good. Use the GeoGebra app to plot and the points and draw the function. Okay, so I think instead of using the GeoGebra app, I will just use the graph paper from the GeoGebra app. Oh, I already have the I already have the graph paper from the previous year. So let me go back here. Okay, good. So let me just get it. Yeah, I just use the graph paper. Okay, so if you don't want to use the GeoGebra app, up to you. I'm not forcing you, but you need to know how to use the graph. All right. Let me get the table. The table is this. Okay, good. Yeah. Okay, good. So very quickly, -2, -3, -2, -3, -1, -1, 0 and 1, 1 and 3, 2 and 5. Okay, let's say I purposely make a mistake, 3 and 8. Actually, 3 and 7, I choose 3 and 8. I purposely make a mistake. What is going to happen? You cannot link up. Can you see you cannot link up all the points? If you make a mistake, you cannot link up the points together. Can you see that this one is not linked up? This one is not linked up, and this one is a bit off also. If you make a mistake. Can you see that? So if you realize that you cannot link up all the points together, so that means somewhere is not right. Somewhere is not right. Okay. So it should be 3 and 7. Which you see. Then now I think you can link up. Yeah, done. Can you see? I line up all the points. It means the straight line goes through all the points down. Okay. So now the question I ask myself is, free range and free scale is the question. Free range and free scale. Let's look at the question. Anything they say? No, nothing. Free range, free scale. Up to me. Okay. Free range, free scale. Because they never talk about the range, they never talk about the scale. Okay. Free range, free scale. Okay. Now draw this on the graph. Y minus x equals to 1. How do you draw y minus x equals to 1? Simple. Okay. How do you draw a straight line just now? Give yourself a table of x and y value. Okay. So -1, 0, 1, 2. Why I choose -1, 0, 1, 2? Free range, free scale. Because they never say anything. They never say anything. I choose my range, I choose my scale. So with -1, you put it in, is 0. 0, you put it in, 1. 1 equals 2, 2, 3. Basically, you just get it into this. You get the x and y values table. Okay, this one is called the x and y value table. A table of x and y values based on this table is based on this. Okay, this table is based on the y equals to 2x plus 1, if I remember correctly. Yes, yes. So y equals to 2x plus 1 for this table. Okay, so don't confuse the two. This table can be explained by this function. Okay, this table here, okay, can be explained by y minus x equal to 1 function. So different function, you have different table. It makes sense, right? It makes sense because different function, different values of x and y. Does it make sense? Does it make sense to you? Why I need another table for another function, and why this function has this table? Okay, yeah, pretty simple. Okay, good. Now I can actually sketch this out. -1 and 0. This is -1 and 0, right? -1 and 0 is here. 0 and 1, 0 and 1. Oh, same point. 1 and 2, 1 and 2 is here. 2 and 3, 2 and 3 is here. All the red one. So just link them up. Okay, good. Okay, good. So label. This is my y minus x is equal to 1. This one is my y equals to 2x plus 1. And then this is the x-axis, and this is the y-axis. So far so good. How you sketch. What's the next question? Label all x and y intersection points on the graph. Simple. Just read. Just read. Let's look for the x intersection point first. X intersection point, I see 2 points. I see this point, which is -1 and 0. And I see this point. This probably is because in between, so it's in between, so it's very hard to see. Okay, so I guess it's -0.5 and 0. So these 2 points are the x intersection point. X intersection point means the point that cut the x-axis. Points that cut. I explain points that cut x-axis. So y intersection point. So let me do it here. Y intersection point. Y intersection point. So the meaning of it is points that cut the y-axis. Points that cut the y-axis. So I see just this point only, because they both cut this point. So this point is what? This point is 0, 1. Okay. Okay. Oh, by the way, let me caution you. Let me caution you. A lot of students make mistake also. This point, the one I circle black here. Okay. This point is 0, 1. Okay. But this y-intercept is 1. What's the difference between these two statements, by the way? What's the difference between these two statements? Any idea? Okay. Always remember, if you are given a graph, let's say this is 0, this is 1, this is 2. This is a point. Okay. This point is 1, 2. So this is a point. Let's say I call it point A. So point A is given as 1, 2. This is the format. This is the format to name a point. Name of a point on the graph. This is the format. Okay. But y-intercept. Y-intercept is when they ask for the y-intercept, right? They are not asking for the point. They are asking for the value of C, the value of the y-intercept. So it's the value of C. So value of the C is, so if you have the straight line, so the value is not 1, 2. The value is actually 2 in this case. That's how you differentiate. Okay. This one is a point. Okay, this one is a point. So it depends how the question asks you. If they ask you for a point A, you give in this format. But if they ask you for the y-intercept, which is the C, and which is a value, then you need to give it a value. The value is 2. in this case. Are you clear? So value and point, two different concepts. Okay, value and point, two different concepts. All right. So let's come back to this. Yeah. So yeah, that's it. And something I want to talk about here is so basically, I think this concept is not brought across to you or has not been taught to you when you were taught simultaneous equations. You have y equals to 2x plus 1, and you have y minus x is equal to 1 from here. Can you see? You have your equation 1, y equals to 2x plus 1. You have your equation 2, y minus x is equal to 1. Okay, so I have just copied the two over here. Okay. Without learning graph, how do you solve this one? You are solving it using calculator, right? One of the way, calculator. Okay, but of course, before you can use calculator, you need to rearrange. You need to rearrange the one first. So when you rearrange the one, you get minus 2x plus y is equal to 1. And then for this one, you need to rearrange is minus x plus y is equal to 1. So what you're going to key into the calculator, you're going to key in minus 2, then 1, and then 1 for the first row. And then you're going to key in negative 1, 1, and 1. Can you help me out? Use your calculator. So what's your x and what's your y? To solve this simultaneous equations using your calculator. So are you helping me out? I hope you are. You know how to use the calculator to solve this? Oh yeah, good, thanks. So okay, so you were saying x is equal to 1, y is equal to 0. I really doubt so. How do you get this? You're supposed to key in minus 2, 1, and 1, and then minus 1 and 1 and 1. You're not supposed to get this x equal to 1, y equal to 0 using a calculator. You want to double check? Can you key this into your calculator and double check? I think it should be x is equal to 0. Yeah. Yeah. Switch. Yeah. Okay. So x is equal to 0, y is equal to 1. Okay. You know why I make the call just now, like it should be, you should switch the two values, because just now you say x is equal to 1, y equals to 0. Somehow I sub this into this is equal to negative 2. It's not equal to 1. So I know that it's not right. Okay, never mind. So the answer is x equal to 0, y equals to 1 using the calculator, right? That's one way. What is the other way to solve this? If you don't use calculator. Calculator is very fast. But what if you don't use calculator, you use some other methods, right? Manually. How? This one is equal to y. So this one, you just replace your y. No? So it's 2x plus 1 minus x is equal to 1. Okay? So basically your this y, right, is this y is replaced by this whole thing. Yeah, you see. Okay. So y is gone, replaced by your 2x plus 1. So you put it in, so you get this. So once you get this minus x. So similar term, minus, you get x. Plus 1, this is plus 1, you bring it over. So 1 plus 1, you bring it over, becomes minus, change the sign. So that's why I get x equal to 0. So when x is equal to 0, you put it back in. So 2x plus 1, 2 times 0 plus 1 is 2, or is 1, because this is 0. Okay, so y is equal to 1. X equal to 0, y is equal to 1. So this is manual method. Okay, you learn this from someone else. Okay, so both ways. Calculator, very fast. X equal to 0, y equal to 1 after keying it all this. By the way, I want to caution you again why I need to rearrange them before I key it into the calculator, because the calculator format is x first, y next, and then value on the right. You need to follow this format. If not, you don't key in this format, right? Your calculator is not going to give you the correct answer. Okay, so that means you need to get it into this format first. That's why I do a conversion first. That's why I do the conversion here. Okay, so this is by calculator and this is by manual, right? Calculation. Let's look at our graph here. Can you see that this point is what point? This point is where your blue line, can you see your blue line? This is your blue line. 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 The orange line. So the blue line is represented by this, the first equation. The orange line is represented by your second equation. And the intersection point of these two lines, which is here. Can you see the intersect here? Intersection means cross. Just like the junction, okay? Just like the junction, okay? Crisscross. So this point is your 0, 1. So this 0, 1 is x is equal to 0, y is equal to 1. So what I'm trying to tell you here, can you make a guess? What I'm trying to tell you here, can you make a smart guess? Am I trying to tell you something here? Or you still don't know what I'm trying to tell you? So what I'm trying to tell you here, I show you how you solve equation 1 and 2 together using calculator first. I show you how you can use manual method to solve equation 1 and 2. And now I come back to the graph and I show you the intersection point of these two equations or functions is x is equal to 0, y is equal to 1. What do I want to tell you here? What's the conclusion? After talking so much, calculator method to solve, manual method to solve, and then now the graph. So what do I want to tell you here? Any idea? No response. You're trying to write something? No idea? Or some idea? Or in between? The difference between the difference between calculator and manual and graph. Okay. Okay. I show you calculator method, which is here. This slide. You get x equal to 0, y equals to 1. I show you the manual method, x equal to 0, y equals to 1. And ultimately, I show you the graph, x equal to 0, y equals to 1. Not only I want to show you the difference between the calculator and manual method, I want to show you to solve y is equal to 2x plus 1, y minus x is equal to 1. You can use the calculator to solve. Calculator. You can use manual. And now you have learned graphing. The third method to solve is graphing, or by graphing. Or normally we call this the graphical method. Okay. This, the calculator gives you x equal to 0, y equals to 1. This x equal to 0, y equals to 1. Then this also gives you x equal to 0, y equals to 1. But this one, the graphical method is a bit, I will say it's not so straightforward. They give you in this format. And this point is the intersection point. Intersection point of the two lines. Okay, so a lot of students, they have not learned this method yet, graphical method for this. Do you know when is it easier to use the graphical method? You must be asking, hey, why do I need to learn the graphical method? Wow, I know the calculator method. Wow, I know the manual method. When do I need the graphical method? Is it better? Is it faster? It does not look like it's faster, right? Why? Because first thing first, you need to create the first table for this, and then you need to create the second table for the second equation, and then later you need to draw it out. Troublesome, right? Troublesome, right? So how can this method have its value, right? Right? How can this method have its value? I could have used calculator and manual, right? I could have used calculator and manual. I can quickly get the answer out. Okay? So I'm going to talk about this in the second half of our lesson. Okay? Okay, so let's take a 5-minute break. We go for a 5-minute break before we talk about what value the graphical method have. All right? See you in 5 minutes. All right? Yeah, welcome back. If you are back, just let me know. Yeah, welcome back. Yeah, just to catch up on what you are learning in your school. Yeah, what are you learning in your school? Which topic?
Algebra.
Good. Is it easy for you? Factorization, expansion, or which concept of algebra? Can you just explain by writing using the cameras? Set equations, expression, combine them together, that kind of stuff. Something like this, like 2x minus 4 plus 3x, something like this. And these two you can combine, so you get 5x minus 4, something like this. Okay, good. All right, so we have done this, by the way. If you refer to our homework, I think homework 9, yeah, homework, I don't know, maybe 8 to 12, yeah, that period, yeah, we talk about this. And by the way, you are having your holiday, right? 1 week holiday, right? Right now, okay, 1 week, right? Okay, good. Yeah, yeah, 1 week holiday is for you to recharge yourself. Yeah, so just rest. If you want to go out, enjoy yourself out. Okay, be positive. I mean, your mentality is positive. Okay? Not anything else. Okay, yeah, let's talk about why the graphical method has its value in this world. Okay, why the graphical method has its value. Okay, so you must be thinking. Okay, let me just. Am I recording? Yes. Okay, good. So questions like this, y is equal to 2x plus 1, and then y minus x is equal to 1. Okay, questions like this, equation 1, equation 2. I think questions like this, they are too easy to solve, right? Too easy to solve. Meaning what? Too easy to use calculator or manual to solve. Okay? But what if you have this? By the way, you are going to solve this not today. Like if it's not the second half of the year, then it will be next year. Sec 2. Might be second half of the year. Okay. So how are you going to solve this? Okay. Calculator can't help you for this. Calculator cannot. Okay. Your calculator is not powerful enough. Not that calculator cannot. Your calculator can. And your calculator, I mean, there are many calculators out there. Yours is just the basic version. Okay. So your school also does not want you to have a very powerful calculator which you can solve all questions. Okay. So your version of calculator cannot. Okay. Your school also does not want you to have a powerful calculator. Manual, yes, can, but very, very tedious. Tedious means a lot of steps involved, and then a lot of work involved. Okay, very, very complicated. Okay, so therefore, the value of the graphical method, the value of the graphical method, it shines in this case. Let me show you. So you just use the okay, you just use the GeoGebra app. So just key in y equals to x, and then this one is 2, then plus 1. Enter. So I have my x y equals to x squared plus 1 out already. Can you see the graph on the right? I'm showing you the graphical method to solve this this more complex question. The second one I need to key in is x squared minus 1 equals to y. Okay, good. So x squared, so x squared minus 1 is equal to y. Okay. 8, 7, y. Okay, good. Done. Can you see? Can you see the two graphs? And what do you observe? After getting the two graphs out, what do you observe? What do you observe? Is there any intersection or not? Do they intersect? Any intersection point? A bit hard to tell, because I need to go very like now the y value is only 100 plus. Probably they intersect in 1,000. So meaning what? Meaning this question, right? Let me fine tune it a bit. Instead of x squared, right? Instead of x squared, probably let me just fine tune it so that you can see the result. Just get it into x minus 1 equal to y for the second. So instead of x squared, it's x. Let's see. So I zoom in. Okay, so now you can see. Is there any intersection? The answer is no. There is no intersection. Given these two functions, there is no intersection. So what does that mean? No intersection means what? No x and y. So if you are given these two, they don't intersect. They don't intersect using the graph, meaning no x and y. No answer for x and y that can fit these two equations. Okay? That means no answers. Like I say, no answer is also an answer in secondary school. You need to explain. You explain by this. So since the two of them, they don't have intersection points, so there is no solution, or there is no answer. There is no x and y. Are you clear? So the value of this graphical method is this. Very clear cut. You want to see the answer, they must have an intersection point. They don't have intersection point, no answer. Right? But if you are going to use the manual, okay, calculator, like I say, cannot already. If you are going to use the manual method, I think it's pretty hard. Okay, so let me just change the equation one more time. Let me change it to +1. See if they have intersection point. I also don't know, because I just create this question off the cuff, spontaneously. Plus. Oh, now they have intersection point after changing it to +1 equals to y. You see? Zoom in, zoom in, zoom in, zoom in. Can you see that they have two intersection points? Which are the two intersection points? First one and second one. Then you click on it, you can see that, oh, they intersect at 1 and 2, and they intersect at 0 and 1. So basically what this means is, if I were to answer the question here. So let me just get this. Hold on, let me just try to see how I can make things easier for you to. Let me just get this out to this PowerPoint. So given this, okay, by solving it using graphical method. So if you can't see it, just let me just rewrite it. So this is your equation 1, equation 2. You are using graphical method. The answers are, you have two answers. So basically you have the x1, y1. You have the x2, y2. To represent that you have two solutions. So this is the first pair of solution. This is the second pair of solution. That means this pair fit the two equations above. This pair fit the two equations above. So the first pair is this one. It's 0 and 1. 0 and 1. This pair is 1, 2. So it's 1 and 2. Simple, right? So this is the value of the graphical method. Are you clear? Okay, yeah, very good. So I hope you appreciate, okay, I hope you appreciate the beauty of using the graphical method to solve any simultaneous equation. Okay, so next time, if I don't know, maybe in your infinity program, you are given this. This looks very complicated, right? Y squared x cubed. There's no way you can solve using calculator, your calculator, and manual. Okay, for your this stage. Then you can actually do it using graphical. How do you do it graphical? Create a table for this first. So x 0, 1, 2. Y, so this is -1, and this is 0, and this is 3. Of course, you need to give yourself a few more points, because this is not going to be a straight line. This is not a straight line, by the way, not a straight line. It's a curve. So you create another table for this of x and y. It's a curve. So if it's a curve, you need a few more points. So once you get them out, then you can sketch. Once you sketch, you can get the solutions by looking at the intersection point, if they have. Okay, so yeah, so this is the, I think you are going to I'm not sure if you ever reach this, but basically this is the value of the graphical method, why you need to learn how to graph. All right, so let's go to the next question. This one is I don't know how you get this one, by the way. Okay, but anyway, you can actually read the question. It says what? Pump in 1 liter of water per minute. So another minute, another 1 liter. So it's 4. Another 1 minute plus another 1 more. Okay, good. So the table is out. So once you have this table, you can draw the graph. So this is the table for you to draw the graph. Okay, so once again, I make use of the graph I have. So just make use of the graph I have just now. Okay, it's here. copy, paste. Good. So I need this table. Right. Okay, good. Something is something is different in this case. The time t in minutes. So basically, this is your time. This is t and not x, because they are talking about time already. So the unit is minute. You can put it like this. And the y-axis, I mean the vertical axis is no longer y, it's volume. So it's volume. I put a v, and then the unit is L. That's how you label. Okay. First point, 0 and 3. 0 and 3. Next point, 1 and 4. Here. 2 and 5. Here. 3 and 6. Here. 4 and 7. Yeah. Oh, okay, good. Done. Link it up. Very fast. It's a no-brainer. I mean, it doesn't require a lot of brain power. Hopefully for you. Done. So once you label it, so this is your. Did they give you the equation? If they don't, you just write y equals to mx plus c. Okay, by the way, in this case, it's not y, not x. Because in this case, is v and t. The v is your vertical axis. The t is your horizontal axis. So you need to change accordingly, according to the question. So I just want you to know, like, y equals to mx plus c is a general formula. But things will change if the question change. Okay? So v is equal to mt plus c for this. So now, what's the next question? They say use your graph to estimate what's the volume in the jump at 2.5 minutes. Very easy. 2.5 minutes. Where's your 2.5 minutes? Zoom in. Estimate. So 2.5 minutes is here, right? This is 1.5. I'm sorry. So this is 1.5 minutes. So I'm supposed to go to 2.5. So to 2.5, you go up. Use a ruler, of course. Then what is the volume? Yeah, about 5.5 liter. So you need to show this. You need to show exactly like what I show here using a ruler. Okay. Next, what's the next question? Use your graph to estimate what's the time needed to fill 6.5. Okay, 6.5 liter, right? 6.5 liter is here because this is the liter. Okay. So come down. So it's about 3.5 minutes. Okay. So this is 6.5 liter. Okay. Done again. So the next question. Oh, they ask you what's the y-intercept in this case. They ask you what's the gradient. Simple. So how do you get the y-intercept? So like I say just now, y-intercept is a c. C is the value. So where it intercept the y-axis or the vertical axis in this case. Okay. So this point is the y equals to 3. So c is equal to 3. Okay, pretty simple. What is the m gradient? So use the formula y2 minus y1, x2 minus x1. So what's your y2 and x2 here? Choose 2 points. So let me choose this is my x1 y1. This is my 0 and 3. Then let me choose this point. This is my 4 and 7. Okay, this is my 4 and 7. So I just replace. My y2 is 7. So this is my x2 y2, by the way. This is my x1 y1. So this is 7. This is 3. This is 4. This is 0. So what you have? 7 minus 3, 4. 4 minus 0, 4. 4 divided by 4, 1. Done. The gradient is 1. So now you can put it back in. So V is equal to 1t plus 3. Simplify it a little bit. V is equal to t plus 3. So this is the equation. So you don't have to write this. You just write. This is the equation to represent this line. Simple, right? Okay. I hope it's pretty simple. Yeah. So what is the function which describe the equation? Yeah, I have got it. It's y. No, not y. In this case, it's v equals to t plus 3. Y-intercept is 3. Read from the graph. Then gradient is 1. Formula. Okay. Yeah. By the way, I have demonstrated to you how to do this question already. Which slide shows this? Just now, graphical method. But just now the question is y equals to 2x plus 1. Y minus x equals to 1. I'm doing this too just now. So similar. And by the way, you are given a range. You are given a range here. Can you see? There is a range for x. So you must follow. So basically, you cannot choose any value. You must choose. Okay. 1 cm, 1 unit. So for the x is minus 2 to 3. Minus 2 to 3. Okay. Okay. Then of course you need to give yourself a table for the. So you need to give yourself a table for this first equation. And then you need to give yourself a table for the second equation. So once you get these two tables, then you just sketch the two out. Sketch the two out on the same thing. Then you can get the answer. So I'm not going to demonstrate to you, but I can use the app GeoGebra to quickly show you the answers. All you need to do is you key in y equals to 2x plus 3. So 2x plus 3. Okay. Then the other one is y equals to x. Y is equal to x minus 1. Okay. Let's see. Zoom in a little bit. Can you see? The intercept at what point? Here, here, right? Over here. So zoom in a little bit. Click on it. -4 and -5. Okay. So -4 and -5 for this question. Okay. So x is equal to -4, y is equal to -5. Okay. So this is graphical method. Okay. So you can actually use a calculator. You can use a calculator or manual to verify. Okay. To verify. All right. Okay, good. Yeah, same thing. You see, solve. Okay. So you can use 3 methods: calculator or manual, or the latest one, graphical. This one also same: calculator, manual, or graphical. Okay. So over here, this one same. You can use one of the 3. Okay. All right. We still have some time, and today I'm going to talk about more in depth into the gradient and the intercept. How? Because we have been talking about what? We have been talking about this y equals to mx plus c. Okay. We know that this is the gradient m. This is my y-intercept. And I have not talked about how the gradient and the y-intercept will change the straight line. That means what is the effect of M and C if they increase or they decrease. I still have not talked about the effects. So with the balance of the time, let's talk about the effects. So in order to talk about the effects, it's important to use this tool, the GeoGebra app, because this tool is going to help me graph equations or functions very fast. So let's decide. Let's fix the gradient for the moment. So what is the commonality? Okay, what's the commonality among these three equations? So this is m equals to 2, c is equal to 1, this is m equals to 2, c is equal to negative 0.5, so this is m equals to 2, and then c is equal to negative 1. Okay, so the commonality among these three equations is the gradient are the same, or 2. And by the way, not only 2, positive 2. Positive 2. And then these similarities are they have different y-intercept. Different y-intercept. So once again, y-intercept is a value. Okay, so different. So let's graph these three and see what is the effect. Okay. So mathematically, you see it here already. But how does it affect the appearance of each of them? Just get into a split screen. Yeah. So I go to split screen. I need to use left half. Then I need to use right half. Okay, good. Still looks not very good. So just align it a little bit so that it's easier for me to see. Make this bigger. Yeah, okay, good. So zoom out a little bit. Okay, good. Zoom out a little bit. All right. So first one, 2x plus 1. 2x minus. So I can delete this. Then let me just duplicate this. So I just need to change the minus 0.5. Then I duplicate one more time. This one will be minus 1. Okay, good. I have graphed all of this out. Okay, so let me zoom in. Okay, I hope you can tell from the color. The first one is blue, which is here. Second one is purple, here in the middle. Oh, by the way, something is not right. This is minus 1. Sorry. So the third one is gray, which is here. Can you see the three in different colors? And the commonality, okay, the commonality among the three is positive 2, right? The gradients are the same, right? So when the gradients are the same, what conclusion you make here? Based on their appearance. Any conclusion you can make based on the appearance? So all are m equals to 2. M is equal to 2. M is equal to 2. So let's not use m only. Let me call this my m1. It means the first equation. M2, second equation, second gradient. M3, so third. So that's how you differentiate different m, just like how you differentiate the x and y just now, y1, y2. So they all have the same gradient. So what's the conclusion here? What's the conclusion here? Okay, so m1 is equal to m2 is equal to m3. That means the gradient are all the same. Therefore, what's the conclusion? What's the conclusion? The conclusion is no conclusion. I think you can read their y-intercept. This one is 1. This one is C1 is 1. Then this one C2 is negative 0.5. Then this is C3 is negative 1. So what's the conclusion? Line 1 parallel line 2 parallel line 3. Yes. That's the first conclusion. First only. What's the second conclusion? Over here, M1 is equal to M2 equals to M3 and is equal to positive 2, right? Can you see it's all trending up? This is called trend up. Trend up. Upswing. Okay, I call it trend up. Or you can call it the slope. Slope upward. Okay. Okay. So if you have a same gradient and it's positive, okay, so this is same gradient. Same gradient, parallel. Positive gradient, trend up or slope up. Okay, so these are the two conclusions. Okay, next, let me reverse. Reverse means I don't want to play with positive gradient. Let me play with negative gradient or negative gradient. So what has changed? What has changed? The gradient has changed. The gradient, can you see? All over here, the blue line, right? So what has changed is, so now the y-intercept has no change. Can you see? The y-intercept is still, the C1 is 1, the C2 is still negative 0.5, and then C3 is still negative 1. Y-intercept no change, but what has changed? M1 is equal to M2 is equal to M3, and they are all negative 2. So the two conclusion is, so same gradient, right? Parallel, line 1 parallel with line 2, parallel with line 3. That's the first conclusion. But over here is trend down because it's negative gradient, negative. So trend down means slope down. Can you see slope down, right? Downward. Okay, hold on. Okay, so gradient. So amazing, right? Amazing. So these are the two conclusions. If you change the sign of the gradient, okay, slope up, upward, trend up, positive gradient. Negative gradient, trend down, slope down. Okay, but they remain the property of parallel with each other. Okay, but just that the slope is reversed, up down. Okay, all right. So I have tested the impact of the gradient. Okay, the impact of the gradient, right? So now I think in the previous question, previous lesson, I also talk about what about, so over here we talk about common gradient. So same gradient, parallel with each other. So what about different gradients, right? With same different gradient with same y-intercept. Let me choose 2x. So the commonality here is, so just write down the m first. This is 2, 1.5. Then this c is 2, c is 2, c is 2. So the commonality among these three equations is y-intercept is the same, or c equals to 2, but different gradient. And let's see how different gradients affect your this graphing. All right, so let me just clear all. I don't want to say. So that's why I say this tool is very, very helpful, especially when you need to see the impact of a few equations. So plus 2. So just key in y is equal to 2x plus 2 first. Then duplicate. I duplicate. So I get 1x. Yeah, I get 0.5x. Okay, good. Purple, green in the middle, light blue last. So let me just get this out. And we will see the impact here. So they go through the same, okay, they have the same y-intercept. So yeah, all of them cut the y at 2. By the way, the point is 0, 2. But the y-intercept is, actually I should not use y equals to 2. I should use c equals to 2. Okay, they cut through the same point. Okay, and because of the different gradient, right, I still remember this is m1 equals to 2. This one is equal to 1. This is m2 already. This is m3 equals to 0.5. So, and they are all positive, by the way. Okay, positive 2, positive 1, positive 5. So you will see that. What's the conclusion? Number 1, trend up or slope up. Because positive gradient. Okay. What's the second conclusion? You look at the slope. This one is very steep, right? Okay. And then this one is more gentle. Right? More gentle slope. Not so hard to climb. And then this one is the easiest. The easiest to climb. Imagine you need to climb all the slope here. Okay. Imagine. Wow. This one. Okay. So basically, if I'm talking about positive, positive gradient, because my first conclusion is must trend up and slope up. So M is more positive. So the slope, I'm talking about the slope now. The slope is more steep. Okay. If the gradient is more positive, it means bigger, the slope is more steep, as you can see here. Harder to climb, basically. More steep means harder to climb. Right? Okay. Next. What about negative gradient? So let me just change it to negative gradient. Negative 2. Negative 1. Negative 0.5. So what do you see? Let me just get it to the slide. Then you can see. Okay, so y-intercept is all the same. Cut through c equals to 2. Yeah, all the same. So this is M1, M2, and M3. So this is -2, this is -1, and this is -0.5. So imagine you are the person. Imagine you are the person on each of the slope. Okay. By the way, this because the gradient is negative, so M1, M1, M2, and M3 all negative. So first conclusion, slope down or trend down. What's the second conclusion? Okay. By the way, this one is larger, right? -0.5. Okay, basically is -0.5 is bigger than -1. Is bigger than -2. But we are talking about negative value here. So in a way, right? You can also write -2 is smaller than -1 is smaller than -0.5. So that means what I'm trying to say here, more negative. Okay, what happened? Easier to slide down. You see, this one is very slow. This one is also even slower. So more negative is more steep downward. Okay, it's very intuitive. Intuitive means instinct, right? It's not. It's easy to grasp. Does it make sense? Does it make sense or not? Okay. So I have just finished teaching you almost everything in this chapter already. Okay, the impact of gradient and the impact of the y-intercept. Okay, actually the y-intercept is very easy to grasp. For y-intercept, right? What's the impact? Okay, y-intercept, if you know the definition, points that cut the y-axis. So basically, you give me y-intercept equals to 2. I'm supposed to see it cut the 2 here. If you give me c equals to 1, I'm supposed to cut it at here. This point, y equals to 1. Okay. If you give me c is equal to 4, then I'm supposed to cut the y-axis at 4, which is here. So for the y-intercept, is very clear cut. You give me c equals to 4, I cut y at 4. Okay. You give me c equals to 2, I cut y at 2. You give me c equals to 1, I cut y at 1. Very simple for y-intercept. And then for the gradient, right? Then you need to talk about whether it's positive gradient or negative gradient. For positive gradient, slope up. Negative, slope down. Okay. And then for slope up, right? More positive, more steep upward. More negative, more steep downward. Right? So more steep downward means what? More steep upward. Okay, upward. We are talking about upward, positive. More steep upward means what? Harder to climb. Harder to climb. Okay, you just imagine yourself on the slope. So it's bigger or more positive. It's very, very hard to climb. So more negative, more steep downward means what? Easier to slide down. Easier to slide down. All right. So that's why then you will end up with, so like I say, more positive is harder to climb, right? Wow, this one is so hard to climb. Harder than this one. So this is person 1, this is person 2. So person 1 has more difficulty climbing. Person 1 has more difficulty climbing up the slope than person 2. So there is going to be a point, right? There is going to be a point that is a straight line. Upward. Vertical upward. Vertical upward. Or vertically upward. So vertically upward. So this is what? What does this mean? If you reach this vertically upward. So this is person 0. This is person without any label. So this is the vertical upward. This is called person, I call it the ultra. Why I call it ultra? How do you climb this vertically upward slope? When do you get this? When do you get this point? Vertically upward. So let's assume that this is m equals to 2. So this is going to m equals to, must be bigger than 2, because harder to climb. So 3. So let's say this is m equals to 11. Then this is m equals to 22. So what do you think this m is? This impossible task. This is not climbing already. This is called this is, you need to we call it bootstrap. Bootstrap. Bootstrap means like you need to, it's not climbing already. It's basically you need to use your arm muscles and then bring yourself up. Not climb, is bring yourself up. So what do you think the gradient for this vertically upward will be? What do you think? If we are talking about this extreme, right, there is another extreme. No need to climb, flat. This is called horizontally. Horizontally. Yeah, horizontally. Basically, it's horizontal, not horizontally, just horizontal. So what do you think of this M? And what do you think of this M? This is the easiest. Of course, the negative is even, that one is called slide down. That one no need to climb. This one is horizontal, flat. So what's the gradient for flat? The gradient for flat is 0. So that means if you get a flat line, right, your gradient is 0. Are you clear? And then what is this ultimate one? This one is like you need to like bring yourself up. The gradient is infinity. Like too much. Too much. More than 10,000. More than 1 million. Okay? That's why there is no answer. For your level, we don't have to talk about infinity. Anything infinity is no answer. Okay? M equals to 0 is still okay. Okay? So I think this is a very good pictorial representation to talk about positive gradient. Meaning what? you have the two extremes. This is the m equals to 0 line. And then in between, you have m equals to 1, maybe 1 equals to 5, and m equals to 20. And then until this one is the extreme, m equals to infinity. Too much. Impossible to climb. Okay? Then, okay, of course, we are talking about positive gradient here. Then we talk about the negative gradient. Negative gradient means what? You have this deng, deng. So this one is gradient equals to infinity. We are talking about negative gradient now. So this one is more negative. This one is negative. This is negative 0. Let's say negative 1. Then this is should be more. This is more. This one should be negative 0.5 because this one is very easy to slide down compared to this one. Okay, so it has to be less negative because more negative easier to slide down. Okay, so this one will be m equals to 0 also. Okay, so that's how your gradient change for negative. If you need a pictorial representation, this is how your positive gradient will change. Okay, so these two pictures, I think they speak 1,000 words. That means they speak volumes. They speak volumes about the concept of changes in gradient and the impact as a result. Okay, so I will give you questions to explore. I'll give you questions to explore these two. Okay, so the next lesson, I hope you start to use the GeoGebra app because I find it so easy for you to explore the impact of increasing gradient, both positive and negative. Okay, so yeah, today we will conclude here, and yeah, start. I think you can go to your app store and then quickly download this GeoGebra. I think they have a few. Okay, they have a few. So you just download one of them. Yeah, they have this field. So they have the, yeah, just download one of them, GeoGebra graphing calculator. Then you will see yeah, download this GeoGebra graphing calculator app. Then yeah, then you will see the impact very fast. And by the way, there are a lot of great tools here which you can use. And I probably can teach you how you can use this for your entire secondary school career. All right. All right. So any other question before I end the lesson here? Okay, good. So yeah, so stay safe. And then with this 1 week break, recharge yourself. All right. Thank you. Your big thumb. Thanks. Bye-bye. Yeah, thanks. Bye-bye.